I'm showing off today my Govee Ink project. In this project, I read in data from this commercial temperature and humidity sensor, the Govee H5074, and read it out on my project here. Now, the project consists of a bunch of parts, one of which is this nice e-ink display. This is an AdaFruit 2.13-inch e-ink display. I read it in about every 5 minutes and display the temperature and humidity and also the time. Let me show you the electronics. This is the NRF528040, which is a circuit board from AdaFruit. I'm running it in CircuitPython mode. And all it does is read in the Bluetooth from the Govee. It also initializes itself from a PC program, which is the simple Bluetooth current time server program. That's where it gets data to reset the clock, which means that when it starts up, it will actually set the clock correctly every time. Other features is this nice battery. The whole thing is battery powered, recharged through USB. AdaFruit has this set up so it will automatically recharge the battery when you plug it in via USB, which is also how it gets programmed and also how you move files on and off to it. I've got a switch here, in part because I like to be able to turn things off all the way. Let's flip this over again because it's just about to update and you'll get to see the update cycle. But also those two terminals on it mean that I can find out how much power it draws simply by turning the thing off and then shunting it through a multimeter set to a milliamp setting. It actually uses about 2 milliamps of power just sitting and doing nothing, and then a little bit more about every 5 minutes when it updates. You saw the blue light go on. That meant it started up, and now it's waiting to get data from the Govee. It probably already got it, but it's also waiting for a nice even time to go. You can only update an e-ink display about every 3 minutes. I update about every 5 minutes, but I also update exactly on the 5-minute marks. So it's always a nice even display. And when it updates, you can be fairly certain that it actually is the right time. Now you can see the update. It has to go through a whole update cycle every time it updates. It's not a subtle update in any sense. And here you can tell it's updated our time. It's now 2025. Other features I put in is it's always nice to say what the actual project is. It's the Govee Ink Display 2023. And the 4-point-something volts, that's the actual voltage of the battery of here. And the 100 is the battery percentage of the Govee. They send out a battery amount. It also tells me exactly when I last updated. That's useful in case the Govee device is not close. I can tell if it's a recent update or not. If you want to learn more, in addition to this YouTube video, I've got all the source code up on GitHub, and I got a couple blog posts as well that talk about the issues I ran into. How to pull in data from the Bluetooth advertisements of the Govee, how to read in Bluetooth data from a current time server, which is a standardized time server. I've got an app on my laptop to provide that data, which also provides some data about, like, should it be Fahrenheit or Celsius, and how should I display the time. And then lastly, I've got some information on how I got the e-ink to update. It's not always obvious how to make this work. A regular display is super easy to update, but these e-ink displays take a little bit more. And in my blog post, I talk about what it took to make that happen. Anyway, thank you for watching, and I hope that this finds it useful. The ability to read in from CircuitPython Bluetooth is the big feature here, and please read my blog post and read the code to figure out how to make it work for your own projects. Thank you.